Hello students, welcome back to a new mathematics program for grade 9. Today we are going to talk about indices. Well, this video is the second part of a series of 2 videos based on this chapter. Remember that in the first part we have revisited some laws and rules of indices which you have learned in grade 7 and in grade 8. Today in this video you are going to learn some more rules of indices. So students, in this program, you're going to learn about equations involving indices. So students, consider the following equations. 5 power x plus 1 equal to 5 power 3. 5 power 2x minus 1 equal to 125. X power 5 equal to 2 power 5. What do you observe? Well, these equations involve indices where the unknowns are either the index or the base. Before proceeding further with this equation, let me ask you a question. How can we solve such equations? For example, here, if we have 5 power x plus 1 equal to 125, how will you solve such equations? Well, students, to be able to solve such equations, we must use the following rules. That is, if you have a power x equal to a power y, then we're going to conclude that x equal to y. That is, if you have same base, we shall say that the powers must be same. Or, if you have x power a equal to y power a, here the bases are not same, but the powers are same. We're going to conclude that if x power a equal to y power a, then x equal to y, provided that the powers are odd. That is, if you have a power x equal to a power y, x equal to y, here the bases are same, so we conclude that the powers also must be same. However, whenever you have 2 powers which are same, but the bases are not same, according to this rule, we're going to conclude that x equal to y, provided that the powers are odd. That is, here, a is an odd number. So in order to compare 2 numbers in an index equation, we equate the powers for the same base. However, for powers where the bases are equal, we must be sure that the powers are odd. But what happens if the powers are even? Well, students, we will look at even powers in the following examples. Solve the following equations. Part A, 5 power x equal to 5 power 3. Here you will notice that we have same bases, so we are going to conclude that x equal to 3 according to the rule of indices which we have mentioned earlier. Whenever you have same base, we shall conclude that the powers also must be same. So here we have the bases 5 power x equal to 5 power 3, so we conclude x equal to 3. Part B, 3 power 2x plus 1 equal to 3 power 2. Here again, the bases are same. So we conclude that 2x plus 1 equal to 2, solving this equation to find the unknown x, we shall have x equal to half. Part C, m power 4 equal to 3 power 4. Here, the bases are not same, but the powers are same. Remember that we talk about even and odd powers. So here, the powers are equal and even. So m can be 3 and m can be minus 3 also, because 3 power 4 is same as minus 3 to the power of 4. So whenever we are comparing 2 numbers in index form where the powers are same and even, we shall conclude that for the bases, if we have an unknown value, then this value can be both positive and negative. So you must be careful about even powers. Part D, 5 power x equal to 25. Here the bases are not same, so first we need to write 25 in index form. We shall have 5 power x equal to 5 power 2. Here the bases are same, so we conclude that x equal to 2. Part E, 2 power x times 2 power 3 equal to 64. We have two terms on the left hand side and one term on the right hand side, so we cannot compare the two sides. Also on the right hand side, 64 is not in index form. So first we need to simplify the left hand side, and then you need to write 64 in index form. So you have 2 power x plus 3, yx plus 3. Yes, because on the left hand side we have used multiplication law of indices. So if you have a multiplication and two bases which are same, you need to add the powers. So we have 2 raised to the power of x plus 3, and on the right hand side, writing 64 in index form, we have 2 power 6. Now we're going to compare these two numbers. Since the bases are same, we're going to conclude that the powers must be same. So x plus 3 equal to 6, x equal to 6 minus 3, which is equal to 3. Students, I'm now giving you some exercises for practice, where you need to solve these equations. You need to find the value of x. First you have 3 power x equal to 3 power 2, then 2 power x equal to 2 power 6, third part, 2 power x minus 3 equal to 2 power 5, part D, 7 power x equal to 7 power 3 times 7 power 2, part E, 2 power x times 2 power 5 equal to 2 power 3 times 2 power 3, you need to find the value of x, part F, 3 power x equal to 27, remember that you need to write both sides in index form. Then you have part G, 2 power 3x equal to 64. Part H, 6 power 3x times 6 power 2 equal to 216. Then 2 power x divided by 2 power 5 power 2 equal to 2 power 7. Part J, x power 4 equal to 16. Part K, x power 4 times x power 3 equal to 128. And the last part, 2x in bracket power 5 equal to 6 power 5. To be able to solve this equation, you need to remember the different laws and rules of indices. So students, in this program, you have learned how to solve equations involving indices. If you want to have some more information on this chapter, here are some links. So students, this program ends here. Remember that this video was the second part of the chapter Indices. In the first part, you have revisited the different laws and rules of indices learned in grade 7 and grade 8. And in this second part of this chapter, you have learned how to solve equations involving indices. So students, see you soon for another chapter. Till then, goodbye.